Hi, we were looking at what makes LTE Advanced so powerful. Once again, LTE Advanced is the fourth generation mobile communication technology that is driving the world into a new dimensions. Now, what makes LTE Advanced possible? Where do these performance features come from? Well, we were talking about some of them, and we already went through IC and FFR, DSA and COMP. What I have left in this lecture is carrier aggregation, HETnet and small cells, and self-organizing network, SON. Now, one of the things that I'm going to explain here is that carrier aggregation is one technique that enables broadband services to be possible, and HETnet, small cell, and SON are features and functionalities and technologies that actually help each other. All of these three are actually techniques that work together, and I'll explain the details to you now. First, carrier aggregation. Carrier aggregation combines individual component carriers to increase data rate and capacity of the networks, and there are three modes of carrier aggregation that is used in LTE Advanced. One is intraband contiguous, the second one is intraband non-contiguous, and the third one is interband technology. Now, as you can see, first, intraband contiguous is where you're using two frequency bands and they are just adjacent. They are next to each other, as you can see over there. Number two, for intraband non-contiguous, these two frequency bands are in the same band, but they're not neighboring. They are actually separated, as you can see there, where it looks like there are two cups that are separated in distance in the middle. The third one is interband technology, and that's the one that you see there at the bottom. And as you can see, there's a blue area that is the frequency part that is used, and also I'm going to use that orange area over there, which is a frequency band that's in frequency band B. And I use those two frequency bands to support the mobile communication services in a much broadband high data rate way. Now, one thing is that when you're using intraband non-contiguous or interband technique, then the frequency bands that you're using in the carrier aggregation are not neighboring frequency bands. They are separated. They're either separated, they're in the same band, but they're separated in distance of frequency, as in intraband non-contiguous, or they might be actually in different frequency channels. And you pull them together to get a higher data rate, like you do in interband carrier aggregation. In these cases of intraband non-contiguous and interband carrier aggregation, well, in these cases, you actually may need to have separate transceivers for each carrier. In other words, for intraband non-contiguous and interband, these two cases, you may need individual antennas, transceivers, so that you can receive those signals separately and then combine them to achieve the higher data rate services that you want to get. Next, we look at heterogeneous networks, HETnet, and small cell technology. Now, this is a solution to support largely increasing traffic demands. And you're going to use small cell technology in a specific way such that you can support much higher data rates in smaller regions and then combine this together so that all users are supported what they want. Small cell technology can use a small cellular base station, a small eNode B, which can be installed inside a building for CRE, which is cell range extension and capacity improvement. So for CRE and capacity improvement, this is where small cell base stations can be very effective. What's going on is that when you look at the different cells, well, a macro cell provides a few miles of wide area coverage, where small cells can be categorized by their coverage range, which is microcell, picocell, femtocell. Microcell, picocell, femtocell are smaller cells. So compared to the macrocell, which is from the original E node B base station, these microcell, picocell, and femtocells are much smaller. And there they are miniature base stations that support mobile communication in limited smaller areas where proper support or signal reception is not very good. Various techniques to manage heterogeneous networks with different sizes of cells are required. And what techniques do we use? Well, IC, carrier aggregation, COMP, SON, these are the techniques that we will use. The concept of heterogeneous network comes from the fact that in the cellular range where the macrocell exists, there's not only macrocells, there are microcells, picocells, and femtocells all existing. Different size cells are all existing and overlapping in a service area to provide a more uniform, a more well-covered cellular area for the users. And that's what we mean based upon providing networking capability using all these different types of cells from the macrocell, microcell, picocell, femtocell. That's what we mean by heterogeneous network, HETNet. Now, we talk about self-organizing network, SON. Now, this manages complex and diverse cellular technology, such as small cells and HETNet. Automated network setup and maintenance is supported by these self-organizing networks. Once again, we have all these different networks. Some cells are small, very small, some are large. Then we need some type of coordination. We need our cells, our base stations, to be set up and maintained and limit the amount of interference they're going to have on other cells that may exist in neighboring areas. How do we do that? That's where SON technology is needed. SON aims to configure and optimize the network automatically by providing support for expanding number of base stations, diverse network parameter optimization, like controlling the power, controlling what time we're going to use the signal, and things like that. In addition, new evolving wireless technologies. SON functionality include self-configuration, which is for newly deployed base stations, are automatically installed and configured. In addition, self-optimization. Network entities adapt to network conditions and optimize the network parameters for resource management and interference control and other features. Then there's self-healing. Network entities automatically detect system failures or other places that have significant interference, and they apply solutions to these problems. This is the self-healing feature. These three major functionalities make SON technology so powerful, and they make the LTE Advanced Network so good. These are the references that I use for LTE Advanced research and studies, and I recommend them to you for future more advanced studies on this topic. Thank you.